All right, here is a review of your quiz that you took the other day. I'm going to go through and show you how to find all the answers to these questions, and then afterwards you can ask questions to me, and we can try a few practice ones if you're still stuck on a certain target. The first question asked you to list the factors of 22. On your quiz today, it's going to ask you to list all the factors of some other number. All the factors means we're going to go through and we're going to start with 1 and say 1 times what gives me 22? Well, 1 times 22. 2 works, 2 times 11. 3 doesn't work because 2 plus 2 is 4. That's not a multiple of 3. It's not going to work. 4 also doesn't work. You can use your multiplication table if you're confused on this to see. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10 doesn't work, and now we're back to 11. So my factors are 1, 2, 11, and 22. If I'm listing multiples, remember I said before multiples is like multiply, and so we want to think about making this number bigger. So if I'm listing the first 4 multiples of 6, I start with 6. Think about 6 times 1, 6 times 2, that's a 12, 6 times 3, 6 times 4. That gives me the first 6 multiples. Again, you're going to have a question just like this. It's just going to be a different number. All right, so circle the numbers that divide 246. You are able to use a divisibility chart for this. Use your divisibility chart. Read every rule as you go. Many kids get some of these correct and then missed some, or they accidentally circled too many. So what you need to do is first go at the 2 and say, is this number even? How do I know? If the last number is a 2, 0, 2, 4, 6, or 8, then the whole thing is even and we can circle 2. Okay, is it a multiple of 3, or sorry, is it divisible by 3? I'm going to add 2 plus 4 plus 6. When I add 2 plus 4 plus 6, I get 12. Is 12 a multiple of 3? Sure is, so I'm going to circle it. 4, the rule for 4 is that the last 2 digits is a multiple of 4. So is 46 a multiple of 4? If I look at a multiplication table, I'll notice it goes 40, 44, 48, and it skips right over 46. So it is not a multiple of 4. 5, it doesn't end with a 0 or 5, so it is not a multiple of 5. 6 does work because it worked for both 2 and 3. That's the rule for 6. Does it work for 2 and 3? If it works for both, then it will work for 6. Remember the rule for 9? 9 is the same rule as 3, only it has to be a multiple of 3 when you add these up. Sorry, a multiple of 9. So when I add it up, I get 12. Is 12 a multiple of 9? No. And does it end with a 0? No. We're going to do the same thing again for 120. It ends with a 0. 0 is even, so it works for 2. When I add this up, 1 plus 2 plus 0 equals 3. Is 3 a multiple of 3? Sure is. 4. The last 2 digits, and this one was one that a lot of people missed. The last 2 digits is 20. 20 sure is a multiple of 4. 4 times 5 gives us 20. It ends with a 0, so it works for 5. It worked for both 2 and 3, so it's going to work for 6. It adds up to 3. Is 3 a multiple of 9? No, so it doesn't work for 9. But it ends with a 0, so it works for 10. Moving on. Prime factorization. This asks you to make a factor tree, then list the multiplication problem using exponents. So I'm going to start by making a multiplication problem, any multiplication problem I want. I like to break it down as quickly as possible by thinking of the biggest multiplication problem I can use. And then I keep branching it down. 10 is not prime, so I'm going to keep going. 2 times 5 gives me 10. 2 is prime, and 5 is prime, so I can circle those. 2 times 8 gives me 16. And 2 times 4 gives me 8, and 2 times 2 gives me 4. When I count up how many 2's I have, 1, 2, 3, 4, 5. So I'm going to write 2 to the power of 5 times 5, and there's nothing else in my circles. So that's it. A lot of kids made mistakes like saying 4 times 4 equals 8, things like that. Make sure that you double check these. You will have time today. You'll have a lot of extra time that you didn't have the last time you took it to double check, triple check your work. I thought quarters when I thought 75, so I did 3 times 25. 3 is prime, but 25 is not. 5 times 5 works. Okay, and when I look at this, I have 3 times 5 to the second power, since there's 2 of them. I would like to see these in order from smallest to largest, so notice I started with the 2 and then moved to the bigger number 5, started with 3 and moved to the bigger number 5. I did not mark anyone wrong on the quiz for this, but it is the way it's supposed to be written. And lastly, the GCF. There were 2 ways I showed you how to find GCF, and really only one of them works great for the second method, or the second set of numbers, because they're really big. The first way I showed you was to list all the multiples. So we said 1 times 28, 2 times 14, 3 didn't work, 4 times 7, 5 doesn't work, 6 doesn't work. Moving on, 1 times 16, 2 times 8, 4 times 4, and nothing else worked. So we find that 4 they have in common. It's the biggest one they have in common, so that's my greatest common factor. Lots and lots and lots of kids did not write an answer here. Your answer is one number. I see this. This is great. But you have to actually tell me, what is your answer? What is the greatest factor that they both have in common? The biggest factor in both lists. Another way to do this is to do prime factorization or a factor tree for each. So for 115, I'm going to split that up. I'm going to use 5. Let's see. 5 times 23. And that you could find on your multiplication table. Both of those are prime. Here I did 24 times 10, 2 times 5, 2 times 12, 2 times 6. Oops, that is not prime. 6 and 2 times 3. Okay, when I look at these, I have 5 times 23 and 2 times 2 times 2 times 2 times 3 times 5. What is the same from the top list to the bottom if I want to find a pair? My 5s. I don't have anything else in common. So 5 is my greatest common factor. If I had 2 things in my list that they had in common, I would multiply those 2 things to find my answer. All right, it'll be time for questions.